Hello, I'm Changmin Kim from CIDR Lab at KAIST. Today, I'll present our exploration on everyday objects as an IoT control interface. As more and more IoT devices are being installed in our nearby environments, solutions for IoT coordination is in high need. Currently, trigger action-based IoT coordination services such as IFTTT are often used by end users when creating the desired behavior of IoT devices. These services allows us to experience certain level of IoT coordination. However, challenges still exist. First, there are a few types of usable triggers to apply in coordination, and personalized contexts for desired IoT control are often not supported. Second, it is difficult for users to transcribe their needs into programming languages or handle sensor modules and their values. As a result, we observe a lot of obvious and mundane IoT usage that consists of same triggers or simply a duplicate with minor change in details. As a way to mitigate these challenges, we were interested in utilizing everyday objects as a new contextual trigger to control IoT devices. We expected nearby everyday objects could be a generative and pre-equipped material that can be used for IoT coordination. Also, we believed everyday objects can be an easy-to-use and natural interface means for IoT devices that leads to a new type of harmoniously integrated smart environment. With the assumptions, we report the result of an explorative workshop study and two types of design explorations regarding the use of everyday objects as an IoT control interface. The study was held in a form of grouped co-design workshop followed by in-depth interviews. 16 active IoT device users were recruited to ideate their own context-aware smart applications that involve the use of everyday objects. In results, we gathered total 97 cases of IoT coordination involving the use of everyday objects. Participants preferred the combination of object and IoT devices that makes natural causations. They explained such combinations make the IoT control more intuitive and easy to remember. Participants were also interested in augmenting new playful features to their personal belongings and meaningful items. Also, participants expected that it would be beneficiary to use everyday objects when creating shortcuts or flexible routines on IoT devices, assisting forgettable IoT device controls, and controlling IoT devices in a playful and effective ways. We observed that most participants added manipulation phrases when iterating and finalizing their IoT coordination scenarios. Participants explained that detailed expressions such as object usage behaviors would help to avoid unintentional operation of IoT devices and make the result more robust. In general, everyday objects were comprehensible and easily applicable coordination materials for end users. It also held a broad range and new types of unique contexts. We also noticed that faulty choice of objects can easily cause malfunctions of IoT devices. We believe that comparing between objects or choosing the most optimized object would be a critical issue in this coordination approach. Next, we share our scenario movie. We chose the movie as a research artifact to vividly communicate the speculated user experience of the smart environment with everyday objects. The scenes in the movies were developed from 11 representative cases selected from the workshop study. The selection process considered the even distribution of the workshop findings so that the movie effectively reveals the opportunities and challenges of our coordination approach. The finalized video is called A Day in Peter's Life. We share only the part of the video for now, but we hope the people who are interested watch the full clip from the supplementary material or in YouTube. Lastly, we share the design of an exemplary IoT coordination system, which is a proof of concept for our IoT coordination approach. The system requirements and design rationales were derived from the workshop findings and the reviews of related works and relevant technologies. We considered that unobtrusive object sensing, usage behavior classification, and user-friendly coordination method to be critical for the IoT coordination system. We implemented a watch with ring type wearable device. The objects are tagged with RFID tags, and the device detects the held object and user behavior through the accelerometer and RFID reader. Using the Wi-Fi module, the device sends the stream of data to the system. The software part of the system utilizes the received data to proactively create IoT coordination. When the user repeats the sequential usage of an everyday object and an IoT device, the system automatically transcribes and saves the pattern into an IoT coordination rule. Afterwards, when the system detects a similarity between the rules and the real-time user data from the hardware, the system sends a signal to the IoT device and changes its status. The following video explains the software features through the example of coordinating a pen with an IoT lamp. Besides the pen and lamp coordination case, more example applications are illustrated in the pictorial. The exemplary system helped us to identify further considerations needed for applying to a real usage context. To briefly share, different forms of wearable devices should be investigated to expand the usable objects. Methods for preventing unintentional control of IoT devices would be necessary. In a long-term usage situation, maintenance of the archived IoT coordination cases would be required. Last, it would be necessary to investigate a system interface that can integrate everyday objects and conventional triggers. When using the exemplary hardware, object usage data is automatically accumulated in the system. We expect that such data can be further used for a guiding feature by which the system recommends IoT coordination or selects an optimized object among other alternatives. Our exploration primarily focused on idea for a single person in a personal space. Further considerations are needed for the use of everyday objects by the people who live or work together. The current RFID tags can harm the form factor and usability of the object. An intensive tag design to diminish the presence of the tag would be necessary. Last, the majority of the cases from the workshop did not deviate much from utilitarian applications that are mostly focused on automation or efficiency. In some cases, it was expected that users would simply reach for a physical controller instead of wearing the device for a simple task. It would be necessary to identify key values that motivates users to engage in IoT coordination in this way. This is the end of the presentation. We welcome any questions and feedbacks on our work. We hope the research prototypes and the study findings can be a reference for inviting non-digital artifacts in future IoT ecology. Thank you.